All right, welcome to my first ever YouTube lecture. Didn't ever see myself doing this, but a pandemic changes things. Anyway, just before the pandemic, we were getting to the point where we're going to be forming balanced chemical equations. And so it's really, really important in chemistry. It's the number two most important skill in grade 11 chemistry. Number one, obviously, is names and formulas. So we spent quite a bit of time on that, learning those. The number two most important thing that you have to be able to do in order to pass this course is form a balanced chemical equation. Now, what does it mean by a balanced chemical equation? It basically means what goes into the reaction is what comes out of the reaction. And not the substances per se, but the different atoms that make up the substances involved with the reaction. So for example, if 5 carbons go in as various parts of your reactants, 5 carbons have to come out as part of your products. They might not be bonded to the exact same thing, but they have to come out. If 4 oxygens go in, 4 oxygens have to come out. If 3 aluminums go in, 3 aluminums have to come out. So what we're going to be doing today is counting atoms, which is going to seem really basic. It's going to seem really simple, like grade 10s could do it, and well, they can, and so probably can you. But I'd like to review that and then get into the actual balancing. Balancing is key because we have the law of conservation of matter, which basically says, like we were just talking about, 5 carbons go in, 5 carbons have to come out. So let's go over some examples. The first thing would be a straight ahead formula. I've got a rig set up here at my table so you can see a whiteboard. You can see my hands here, you can see the marker and all of that. So I'm going to be writing on the whiteboard, but I'm just going to go over a few examples first. So let's say we had a formula like this, C6H12O6. That's glucose. It's a very common sugar. So we look at that, that tells us, well, there's carbon, there's hydrogen, there's oxygen in that. I can see the carbon, hydrogen, oxygen right there. And if I look at it very simply, there's 6 carbons. That 6 belongs to the carbon. This 12 belongs to the hydrogen. And this 6 here belongs to the oxygen. So very, very basic stuff. You probably understood stuff like this in elementary school, or at least grade 9 or 10 for sure. All right? So counting atoms when it's just a formula, that's pretty easy. So we'll get rid of that. Nice and easy stuff. The next thing we're going to do is we're going to put a coefficient in there. So let's say we had something like aluminum oxide, which is Al2O3. But now we have a coefficient in front of it. Let's take 4. So for some reason, we need 4 molecules of aluminum oxide. Now, important to note, the smaller numbers, the 2 and the 3, these are subscripts. They're like the recipe for the molecule. Aluminum oxide, I need 2 of these and 3 of those. If I have 2 aluminums and 3 oxygens, I can make aluminum oxide. The 4 is not part of that formula. The 4 is a coefficient. It tells me how many of these molecules I have. It's not part of the actual formula. If I take the 4 away, I still have aluminum oxide. If I put a 7 here or a 10 here, it's still aluminum oxide. So, but when we're balancing an equation, this is important, as are these, the subscripts. So now I still have aluminum. I still have oxygen atoms as part of this. But now this 4 acts as a multiplier. Common mistake, people say 6 aluminums because they see the 4 and the 6 and they add them. It's always multiply. So now I have 4 times 2, which is 8 aluminums. And for the oxygen, 4 times this 3, which is 12. All right, so pretty simple. Again, I think in grade 10 you probably understood that. I'm going to erase that very quickly. All right, we also have brackets. A lot of our polyatomic compounds can often have brackets in them. So if we see something with brackets, what do we do there? So for example, CaNO3, 2, calcium nitrate. So again, if I was going over each type of element, I would have calcium, nitrogen, and oxygen are involved with the nitrate. This NO3 is a nitrate. It's one of our polyatomics that we learned about in grade 10 and also refreshed ourselves in grade 11. So if I go over this now and I look at it and I go, okay, well, I've got no number here, but no number really means there's a 1. Of course, we don't show them in chemistry. So this 1, you won't really see it when we do any of these formulas. So I know I have 1 calcium. Now, if we look inside of the brackets, I've got, again, 1 nitrogen. But whatever's in that brackets, I have to double. So this 2 applies to the stuff inside the brackets here. Not the calcium, it's outside. So now 2 times 1 is 2 nitrogens. And for the oxygen, I have 3 inside. I double that, I'll get 6. So pretty easy, right? Again, you're probably thinking, sir, come on, really? But I still want us to be all on the same page. So, and we're starting off nice and easy. You just had a 3-week break of thinking probably anything chemistry. The last one, excuse me. The last example is one that uses both a coefficient in front of a molecule along with some brackets. So this time we'll use 5. And we'll have, let's see, our molecule this time will be, let's go with lithium phosphate. Actually, that's not a great example, but we'll do it. So with lithium, I've got 3 times the 5. Now this 5 applies to this, this, and this. 3 times 5, which is 15. There's a 1 here that we don't see, but it's there. 5 times 1, phosphorus will be 5. And then for the oxygen, 5 times 4, that's 20. Here's a better example. I said I would do one with brackets. I kind of messed up there. You'll have to just live with that. I'm going to mess up more than enough, and I'm already 7 minutes in, so I'm not going to restart. But here's a better example. So let's keep that 5, and we'll go with something like this. So the molecule here is iron 3 chlorate, right? This is chlorate, one of our polyatomics. This is iron, and of course, we know how to figure out what the charge on the iron is. So if I look here, I've got Fe, my iron. I've got Cl, which is a chlorine, and the oxygen that is involved. Both of these two molecules, or atoms, sorry, are involved with the polyatomic. So if we look at this, I know, even though I can't see it, there's a little 1 here, and I know there's a little 1 here, right? I'll draw them in very small in green. They're normally not there. Iron, 5 times 1 is 5. Now these 3's aren't involved with the iron. That 3, remember, is only for the stuff inside the brackets, and that 3 is only with the oxygen. So 5 times 1 is 5 irons. Easy enough. This chlorine. Now I find when we do stuff in brackets that has the coefficient in front as well, it's best to start right next to the element. So we have 1. 1 times 3 is 3. And then 3 times 5, because this is for all of them, 3 times 5 is 15. So I have 15 chlorines. Again, 1 times this 3. This one's for the oxygen. This one's for both things. So 1 times 3 is 3. 3 times 5 is 15. All right? Now my oxygen's here. 3 times 3, right? We're starting right next to it. 3 times, it's always multiply. 3 times 3 is 9. 9 times 5 is 45. It doesn't seem like a lot, right, when we look at this, but there's 45 oxygens involved in that seemingly small little molecule. All right? So that's how to count atoms. All right? So that's basically it. That's the first skill that we have to know. My next video is going to go over how to balance an equation. Thank you, and look forward to seeing the next video. All right, take care.